What's going on YouTube? It's Joel Rivera and it's time to learn something new. Alright, so in the last video that I did, we set up a quick topology using a router on a stick, and I thought I wanted to expand on that and give that topology the access to the internet because, well, as I was saying, that it could be the router on a stick example could be a basic network that you would be, um, hired to do or hired to administrate. So obviously in today's world, there's nothing that we do everything over the internet basically, and there's no job that you're going to be at where they don't require you to at least have internet access. So I I wanted to use EVNG's ability to connect to the virtual networks and have that lab that we worked on last week have access to the internet. So, um, first and foremost, I wanted to say that on my website, you can actually get. I produced a lab um, that shows you how to do the connection for EVNG and connect to the internet, so that allow you to access uh, the internet using NAT Overload. So I'm going to add that in the description down below, but we're not going to follow step by step because obviously it's a little bit different. But I figured I add that in the description down below so that way you guys could access that information because it is relevant. It's just that it's going to be slightly different with our lab, so it's no need to follow step by step like I did with the other lab. All right, so first and foremost, like I said, I'm gonna have in the description down below about the NAT overload and how you do it with EVNG, and I'm gonna show you how we do it in this topology that we did last week. But yeah, I figured that I add that specifically on the website. Sorry, in the description down below, so you can log to my website and see how it's done. I'm probably going to add this video. I don't know if I'm going to create a new blog entry. I probably will create a new blog entry completely that will match this topology. So that way it's not so confusing. If I do, then I'll also add that description once I do that. All right, so without further ado, let's start the lab up. And first thing we're going to need to do, as you can see, everything is powered off. But before I powered it off, I made sure to save all the configurations on the routers. Sorry, the router, the switch, and all the virtual PCs. So I saved all the configurations and then I powered it off. The reason why we're going to power it off is because we need to add a new object, which is a network object. I like to use the cloud when I do it. You can leave these first two options as is, but the type we're going to change it to NAT. All right. Once we get that added to our topology, we're going to connect it to our router, and we're going to use the port Ethernet 0/1, and that's going to be our external connection. All right. Okay, so let's start up all our nodes and start the lab. I'm going to use the logical map to connect. Again, it's a little bit more descriptive and help us remind us of what we're doing in our topology. So connect that way. Let me expand this a little bit more. Yeah, that should be fine. Hopefully it's booted up. Okay, and the first thing I'm going to do is just make sure that the configurations did save. I mean, and which they did, as we see our three sub interfaces are still intact. All right, So the first thing we're going to do, now that we created that link, and we you know create that link from the network object that we used to our router. Now we're going to set our IP address on our router to DHCP. So it's going to gather a IP address from the EVNG server network that it has. So to do that, first we're going to go into global config. We're going to interface that port, which is Ethernet 0/1. And instead of assigning an IP address, we're going to be doing DHCP, as I said. So to do that, you just type IP address DHCP. And we need to enable that port by doing a no shutdown. All right, so I'll let it catch up a little bit, and we see a syslog message showing that it is up. And we should see another syslog message saying that it has acquired a IP address, which it has. Okay, so interface 01 assigned DHCP address 172.29.129.129. And if we were to do, let me exit out of here. If we were to do a show IP interface brief, you'll see it that the port 0/1 has a DHCP address, and the IP address is what I had said earlier from the syslog message 172.29.129.129. Okay, so that is going to be our internet address, right? So if we were to do this on a regular ISP connection, whatever IP address the ISP were to give you, whether if it's a business, they may give you a specific IP address, or they may have you do a DHCP. So we're going to envision this is a small business starting up. Acme just started last week. So we just got our internet connection, and we're going to be doing DHCP for the time being until we can actually pay for a lease line or more expensive line, more business line. Okay, so we're just pretending that that is a publicly accessible IP address. It is not, but for all terms and purposes for this network, we're going to pretend that is. Okay, so now that we have an IP address from our ISP, we should be able to ping out to the internet. So to do that, I'm just going to use Google's public IP address. Google's public DNS IP address, which is 8.8.8.8. And as you can see, we can ping. Now, if we were to do a ping to google.com, it shouldn't work. The reason why it doesn't work is because we don't have DNS configured on our router. So there's two things. Last week, I did a no IP domain lookup on the router. So we need to reverse that first. And then we need to assign the DNS IP address, which I'm going to use Google's publicly domain name server's IP, which is 8.8.8.8. So to do that again, we're going to go back into global configuration mode. To reverse the no IP domain lookup, we just got to do IP domain dash lookup. And then to set the DNS server, we just do IP name server, and we're going to provide the IP address, which is 8.8.8.8. Now, if we go back, I should be able to now ping google.com. And we can. Okay, so now the router has DNS, and it's able to go to google.com. But without natting, and this is why natting is important, no one behind the router will be able to access the internet. So in order to, to allow our internal network access to the internet, we're going to need to do NAT. And then more importantly, we're going to need to be doing NAT overload, which is also known as port address translation. Why is port address translation? Because uh, you're dynamically configured, or um, you're dynamically natting, getting an IP address, but it is assigned a port per connection that is leaving the network, right? So it does it by ports. So that's why it's port address translation. Right. So we're doing that because we only have one IP address, and if we didn't have more than one IP address, then we would only be able to do one user would be able to have access outside, and that is being consumed by the router. So basically, it would just be the router that would have access to the internet. Everyone else wouldn't. So we need to do port address translation. If we had purchased multiple IP addresses from our ISP, then maybe we can do static entries or dynamic entries. But we only have one IP address in the Acme Corporation, so we need to do port address translation. All right. Now to do that on the Cisco router, we're gonna separate that into basically three different steps. So the first step we're gonna do is assign and identify the NAT inside address. Sorry, addresses, and we're going to assign the NAT inside interfaces and the outside IP NAT interfaces. So we already know what is our outside connection, right? If we go back into our topology, I'm going to show it here. Let's bring it up. Let me do a little cloud, to show my connection. Little cloud, right? And we have the cloud connecting to our router. Boop. And it is on Ethernet 0/1, right? Right. We need to identify. Okay, so what I was saying was we need to identify which one is going to be our outside interfaces, right? So that one's pretty simple. Our outside is our 0/1 connection. That is the interface that is leaving outside of our network. Our inside interfaces are our subnets that we created, our VLANs that we created on those sub interfaces. Now, for practice, I only want to give access to users and our servers. Our management, we don't want them to have access because you're going to use that as an out-of-band management, um, subnet. So I don't want my management devices, which are devices that would be controlling the network. I don't want them to have access to the internet, right? Because if I have access to the internet, then there might be a way for intruders to get in and do malicious things. So I'm going to keep my out-of-band management VLAN separated. So that means that our inside interfaces will be Ethernet 0/0 dot, remember because they're sub interfaces, 24. And our second inside interface would be 0.0 dot 45. We're going to leave 30 alone again. Okay, so this is going to be our outside. And these are going to be our inside interfaces. And I'm sorry for my grammar. It's not the best, but I'm learning how to use this digital pad. But anyways, okay, so now we have identified our inside interfaces and we have identified our outside IP NAT interface. Now we just need to do that on the router. So again, we'll go back to our router. All right, back in our router. I'm going to go into our global config again. We're going to interface our first Ethernet 0/0.25 subinterface. That's going to be our first IP NAT inside interface. And then we're going to do the same interface Ethernet 0/0.45. Is it? I made a mistake. It's not 25. So let's reverse that that configuration. First, let me get back into that interface. I was on autopilot and didn't even realize I had missed. I had put the wrong interface. So back into yeah, I even wrote it down properly there, 24. Anyways, I was thinking about 45 and they here or there. Okay, so now we're in there. Let me remove no IP NAT inside because I don't want that to be the inside interface. And then I'm going to delete that sub interface because we don't need that sub interface. We already have our sub interfaces that we want running our network, so I'm just going to remove that completely by doing a no interface Ethernet 0/0.25. Okay. Now I'm going to make sure that it doesn't appear. So I'm going to do show IP interface brief. Shows that it's deleted. Okay, good. Good. All right. So let's fix that. Now let's go back into the proper Ethernet subinterface, which is 0/0.24. And if I type correctly interface, I'll get to it. Okay. Now this is our inside interface, so we do IP NAT inside. Right? So that's our first interface that is IP NAT inside. And then we're going to move into the next interface. Let me retype interface because I misspelled it again. 0/0.45. And we're going to do the same. So IP NAT inside. Again, these are the two sub interfaces, or the two VLANs that I want allowed onto the network. I don't want anything else. I don't want our out of band management allowed on the network. Okay, allowed access to the internet. Okay. Okay, so we did our inside IP NAT inside interface. Now we need to do our outside, which we, as I showed in the diagram earlier, is Ethernet 0/1, right? Because that's our connection to our ISP. So IP NAT outside. All right. So those interfaces have been properly identified. So the next part that we need to do on a Cisco router to get it to use NAT is create an access list. And the access list that we're going to create is to identify what IPs we want to allow through, to the internet. So those two, the two subnets that we want to allow again are our user subnet and our server subnet. So to do a standard access list, you just type access list 10. I'm going to use 10, but a standard access list would be anything from 1 through 99. or 1300 through 1999. If we're going to do numbered access lists, I'm going to just use 10 because it's just one that I frequently use. So it's just stuck in my head. But you can use any number 1 through 99. Okay, so access list 10, we're going to permit the subnets. So first subnet we're going to permit is 192.168.10.0, and it is again a mask of 25 solder notation. So that would be the 255.255.128 subnet mask. But in access list, we need to do the wildcard mask, which is the complete opposite of the subnet mask. So it's 0.0.0.127. All right. So that will allow our user subnet, our user VLAN access to the internet. And we're going to do the same. So access list 10, permit 192.168.10.160, which is our server VLAN. And the wildcard mask for the subnet mask 255.255.255.224 is 0.0.0.31. All right, so we have permitted both of those subnets. We already identified the two subinterfaces, right? Because those are the where the networks are. The network's gateway. And now we created access lists which are going to permit all the IPs in that subnet. Now, after we do that, the third thing you're going to need in order to initiate NAT overload on our router is the actual configuration of NAT. So we do that by typing IP NAT, and we're going to indicate that it's inside. Sorry, IP NAT. Yes, IP NAT's inside is the source. And we're going to tell it to exit out interface Ethernet 0/1, which is our outside interface. And we're going to overload that because we don't want just one IP. We want all of those IPs allowed. Okay? All right. Did I do something wrong? Yes, I did. Our source is our list, which our access list is 10. So we need to tell it. Let me do this again. Okay. So we need to indicate. We need to actually enter the NAT configuration on our global config that would actually permit the traffic. So we're going to do IP NAT inside source, and the source is that access list 10, which is our standard access list, and interface Ethernet 0/1, and we're going to overload that interface. Boom. All right. So let's do a little quick brief. First, we created the object, the network object. We selected NAT as the type. We connected that object to our router, and we connected that on port 01. We turn on all of our devices, and once we turn on our router, we gained access to our router, and we enabled our outside interface. And we indicated that that outside interface would be grabbing a DHCP address, which it did, which was 172.29.129.129. So that is our quote unquote ISP assigned IP address. After that, we set the DNS server on our router, and that permitted, after we configured obviously and acquired an IP address from our ISP, that permitted the router to be able to do regular DNS lookups, which we use ping www.google.com and got a successful ping to show it that it worked, right? Wrong thing, wrong terminal. Right, and which we were successful in doing right here, as you can see. All right. After that, we identified our interfaces, our PNAT interfaces. Our outside interfaces, which was the easy one, which is our internet connection. So we entered Ethernet 0/1 and we did IPNAT outside. Now for our inside interfaces, we had to do the subnets. The sub interfaces, not the actual physical interface. It is the subnets that we had to enter. Okay, great. So with all that done, we should, in theory, be able to go to our one of our user devices and have access to the internet. So to prove that, first we're going to do ping.8.8.8. Voila, we have access to internet. And let's make and as we did with the router, we do have access to internet, but because we haven't configured a DNS, it won't be able to resolve www.google.com. So to do that on the virtual PC simulator, you just type IP DNS, and we're going to put 8.8.8.8. And now that we have configured a DNS server, we're able to resolve that that URL to an IP address and able to ping google.com. All right, success. That's basically it. We did what we accomplished what we wanted to do, which was provide our simple topology internet access, and then we did NAT on our router to allow our devices inside of the network access the internet as well. All right, in summary, we were successful. We were able to, using NAT, get our basic topology to our basic router and stick topology that we did last week to get access to the internet. And we used EVNG's access to the virtual networks that it provides, which EVNG, one of the many features that I enjoy using is specifically that. I think I'm going to do another video of this network, but I think what I'll do is I'll switch out that server. Yeah, that's what I'll do. I'll switch out that server with a Linux, an actual Linux system, and I might switch out a user and put an actual Linux container next week, and we can do a little bit of some more fancy stuff with the network. Haven't quite figured out what I'll do, but stay tuned. So that's why you should hit that subscription button down below to subscribe to my YouTube channel. Definitely like this video. If you don't like it, hit dislike. That's your opinion. You're allowed to have your own opinion. But if you do dislike, at least write down in the comments down below why you didn't dislike it. It's the only way I can improve, right? But yeah, so quick and easy lab that I believe you'll enjoy if you did the previous lab. Then you can follow along and do this. If not, maybe you stumble upon this video and you learn how to do Cisco natting, more specifically Cisco NAT Overload, or um, also known as PAT, Port Address Translation. I think that's about it for this video. Until next time, bye.